middle of February, but middle of February is very close by and there is still no positive information on when it's going to be held. Everything is come to a standstill. But in the meantime, I suggest you continue with your studies and be prepared for anything. That is what an engineer is like. He has to be prepared for any sudden change in program. And you cannot say at that time, sir, I need to prepare. How can I appear for exams tomorrow? If I tell you tomorrow is your exams, be ready to sit for that exam tomorrow. It should be like that. So expect some surprises and don't start pleading about how to prepare and no time to prepare. You have to be prepared for your 5th semester exams while you're doing your 6th semester course curriculum. That should be the spirit. That means that all times you're ready for any exam. That is what your student life is about in marine engineering. It's not that when something happens on board the ship, they are not going to give you any warning that this is going to happen. It just happens and you have to handle it. Similarly, for your examinations, as I see it, you have to be prepared anytime. If I tell you, all right, tomorrow morning there's going to be a test, you be ready for it. Or even today there will be a test. That is the level of preparation you must have. All right, followers are still coming in. We have 45 only. At 9:40, I will stop admitting. And Pratham, where were we in our last syllabus? Last was, let's see, I didn't have the page written down. Page 14. Saturday for E and F was 14 page. C and D, I didn't have the page written down. E and F, missed class for section A and B. Pratham, can you hear me? Who can hear me? Somebody tell me where we were in the last class. No sound. Oh, come, I hope you can hear.
Sir, it was slide number 32 or 33.
33. Okay. 33.
Excuse me, sir.
Yes.
Sir, Cadet Rajdeep Sahan is from Haryana, and due to the farmer rally, he is facing internet connectivity issue, so he is unable to join the class.
Okay, he tells the class in charge. So when he gives me the number, he will put a remark against it. Unable to join on account of farmers' issues.
Yes, sir.
Okay. Everybody has some difficulty. I try to accommodate as much as I can. Even in middle of the class, if you come in, I don't have objections if the reason is absolutely genuine. But the point is, you have to be alert on your side and absorb as much of the subject as you can. Because ultimately, you are the one who's going to sit for the examinations and you are going to be assessed. And right now, the assessment is strict for one thing. What is more strict is getting placements. They are being so tough on the boys. They are unbelievably tough. And they almost tell you they don't want to take boys. It's like that. And because the whole process of putting a boy on the ship and taking off somebody from the ship has become very, very tedious and very expensive for the company also. 14 days quarantine. During that quarantine, he will have to be paid, he will have to be taken care of, and any medical test that has to be done at the company cost. So these things are very costly for the shipping company. So they are trying to prolong the people who are on the ship so that the stretch of time that a seafarer does is much longer. So ultimately, the cost comes down. So they are finding all the means of cost cutting. So in the process, there are delays of getting on the ship. There are delays of getting off the ship. And the funny part is those who are on the ship, they are desperate to get off the ship. And those who are on shore, They are desperate to get on the ship. It's a very funny situation. Very funny situation with the boys who want to get on the ship, they can't get, and those who want to get off the ship, they can't get off. It's a catch-22 situation. Okay, we have how many? 59. Still very poor. That actually 57. So we were on page 33. As he says, we were on page 33. Yeah, this was the diagram. This was the diagram to show you how variable injection timing was achieved on the Sulzer valve control type of pumps. In the variable injection timing, you need to vary the beginning of injection as much as vary the end of injection. Beginning the uh, Varying the beginning of injection is the time at which the fuel is injected. All right. And varying the end of injection is the quantity of fuel that is being delivered for the injection. Rituraj. So these are the two main issues. I will show you a diagram, which I think is a simpler diagram, and that is this one. Yeah, let's make it a little bigger so that you can see it a little better. Now here it is. This is okay. Some fellows coming to the class. Indrajit Moitro, he's always late. It is 39:37. Another 3 minutes, and I can't keep waiting for you fellows. So, where was that diagram? It caused me a lot of confusion. Yeah, this is the diagram which I taken from the net, but it is very elementary in its display. See, the beginning, the suction valve is on the left side, and the spill valve is on the right side. The spill valve, Divya Prakash. Oh, who's this fellow? Just a second. Hello, Divya Prakash. Yes, what is it? For what? Laurel, so I have already sent all the names that have gone. See what is wrong and right. Don't send me wrong lists because I will forward the wrong lists. I don't have. See, it's the placement committee that is sending me the list, and I have to trust the placement committee. You all make a mess over there. It means I also make a mess. And now I have forwarded already to Laurel Ship Management, and it is up to them now. Whatever they decide, I have to abide by that. They send all the. See, your placement committee has to be very, very efficient. They make a mistake means I also make a mistake. You send me a wrong list, I forward that wrong list. I don't have the scope to whether to inspect that list in detail. So that is why you have a placement committee which makes these lists, which identifies the boys who are going to be provided an opportunity. So you have to be a little serious about this. Don't say random lists and think your job is done and then you realize you have made mistakes. Because what list I get, I have to trust the placement committee. And based on that, I send it to the company. And I can't keep telling the company, sorry, I have made a mistake. Please correct this. Again, after some time, no, that list was also a mistake and I have to amend that list. Where does it leave us? What sort of a institution are we if we keep making mistakes and telling the company it is not right, please amend the list. So one time you send a list, it is final. Don't ask me to keep amending my statements to the shipping company. I lose respect, the whole institution loses respect. And more than that, your boys become unreliable. All the students become unreliable. So be sure that placement committee, when it does a job, it does it very, very thoroughly. Because what placement committee gives me is what I forward to the shipping companies. And my interaction with the shipping company has to be at a certain level where there is a level of trust. And if this level of trust is not there, they will stop coming to a campus. It is very, very important, which some of you don't seem to realize. They keep making mistakes, keep sending whatever they feel like, and then realize there's a mistake. So anyway, that is another point. Let's get back to our subject. So I was explaining to you how variable injection timing can be achieved by adjusting beginning of injection as well as end of injection. So here you have a diagram of the same pump that you saw earlier. In the earlier diagram, you had the suction side fulcrum in a fixed position, whereas the spill side fulcrum was movable, thereby changing the timing at which the spill valve would open and thereby controlling the quantity of fuel that was being delivered. So this is not enough to ensure the best response from an engine in terms of fuel economy. So what we have now is the fulcrum of the suction valve opening is also changed as much as the spill valve. And this is achieved by the governor through one arm here. Okay. Now, if you have a look at the diagram, let's follow this diagram. I have the procedure also written down for your convenience when you happen to read it. First, let me explain to you firsthand of how this leverage mechanism works. And thereafter, we will go into the written statement of how the system is detailed. Okay. So now let's have a look at this governor. This governor here has got only one arm. With the help of this one arm, it is capable of moving two levers which control the spill valve and the suction valve separately. Got it? Or sometimes simultaneously, not separately, but simultaneously. That means if the beginning is advanced, the spill is also advanced. You see, for a certain load, there is a certain quantity of fuel that has to be delivered into the cylinder. Now, if you advance the beginning and don't change the spill, then the quantity of fuel delivered is much more. Okay. What you need to do is to fix that quantity of fuel. So if you advance the beginning of injection, you need to advance the spill also. So the quantity of fuel for that particular load is a fixed figure. Okay. Only thing is that because the engine is running at a higher speed, the ignition delay, the time to come up to the required temperature, and then the combustion process for the fuel to burn completely will not be enough because the piston will have gone down very quickly. At the higher load, the engine RPM is also more. So piston will have gone down. So you be left with incomplete combustion. So that is why you advance the beginning. And that helps in maintaining a peak pressure which is equivalent to the maximum pressure even at low loads. Get it? That is the whole idea. You need to get maximum peak pressure at reduced loads. That means even with the less amount of fuel, you're trying to get the maximum pressure. And this can be achieved by advancing the beginning of fuel injection. So here we have the governor arm, which moves the lever one. Number one is this vertical lever, which is actually moving downwards. The moment the arm comes from zero, you can see the load indicator graduated from 0 to 10. So this is the load indicator indicating how much load is there on the engine. So at the initial stages, there is not much of change. It is at the higher load, the upper load range, that most of the action takes place. Okay. So now when this lever goes down, you see this L-shaped lever will also go down at this end, at the point where it is joined to the lever, vertical lever. So if it goes down, it means this point over here is pulled towards the right side. Number three lever is pulled to the right side, thereby changing the position of the eccentric. This eccentric will shift the fulcrum to the required position to change the spill valve operation. Okay. Now, that is how the spill valve is operated by means of the arm over here. Now, along with the movement of this L-shaped lever, as this number one lever moves downwards, it is also going to move this lever 5 at this point where it is hinged downwards. And if it moves it downwards, it is going to rotate about the axis at A. All right. If it moves about the axis at A, it means this square-shaped plate, which is called a cam, that is number 6, is going to go upwards. If point over here goes down, then the cam, which is rectangular almost, will go up because it is going to move about the axis at A. Okay. Now, this cam, it is called a cam. It has got a slot inside. The slot is a curved slot, you can see. And this slot has a pin fixed within. And this pin is fixed on an eccentric, which has got a base on which it is fixed onto. So when this cam starts moving upwards, it has to follow the path of the slot because the pin is inside that slot. And when it moves upward, it has to follow exactly the slot and the pin entry. In other words, the pin will move only in the slot, but the pin is fixed and the cam is moving upwards. So to follow the slot, the whole cam is going to move towards the right. Sorry, the whole cam is going to move towards the left. No, sorry, I will not admit him. He's coming at 9:45, 9:46. No admission for this fellow. Who is this? Hasib Ali. No admission. Not allowed. Okay. So when this cam moves upwards because of the force of the lever down over here, it will try to follow this slot here. So this pin will actually push the cam on this side because the pin is fixed, pin will not move, but the cam is moving upward. So the tendency of the cam will be to move towards the left. If it moves towards the left, it means it will be pushing at the point where the hinge is. All right. If it is at pushing at this point hinge, at B, it will rotate. So the whole lever number 8 is going to move towards the left at the bottom while it is hinged at point B. Okay. So once it moves towards the left, it is going to move the eccentric at 10, thereby controlling the fulcrum which operates the suction valve. So you see, with one movement of the governor arm, your spill valve is also controlled and your suction valve is also controlled. That means the opening and closing of the spill valve and suction valve both are controlled by movement of the governor. So these are the functions of the levers. You see, also with this, you have a pneumatic piston over here. This pneumatic piston keeps a pressure on this link number 8. Why? To keep it steadily fixed in one place. Otherwise, what happens? There will be some amount of rattle. It will sit moving around at the wherever there are some clearances along the pins and hinges, wherever they are, it will tend to move about. So to keep it pressed in one position, it keeps it actually pressed in this slot. So this pin over here, if it presses over here, it means this full arm is being pressed this side. So the cam is being pressed here and this is a fixed position. So this fixes the position of the cam and this pneumatic piston keeps the lever pressed against this part over here of the link 8. And the link 8 is connected at the hinge 8 to keep the cam pressed in position. So this rattling of the levers is avoided by means of this pneumatic piston. The chief
सर ये वाला
engineer,
पार्ट एक बार और एक्सप्लेन कर दीजिए ना, न्यूमेटिक पिस्टन वाला.
which was the pneumatic piston. Okay. This pneumatic piston has a piston inside and it is pressurized by air, which means the rod which is protruding from the piston is from the cylinder is like a piston. And this rod over here is pressing against the lever, which is number 8. See, this is number 8, which is a long lever. And this lever is kept pressed. And if it is kept pressed, this hinge over here is attached to link number 5. And link number 5 is attached to the cam, which is rectangular. And the cam is fitted inside a pin because there's a slot in the cam and it fits into that pin over there. So when this pneumatic pushes with this rod against this lever in turn will push the lever number 5 and the cam against the pin over here. So the pin is like a locating pin also. And it will stop any movement athwart shapes or sideways or anyway. Because this pin is sort of a pin which is fixed to a base. Of course, this whole eccentric can be rotated, and this rotation is required if there is any changes in the timing to be addressed further. But chief engineer has the option of further advancing the injection with the help of this lever. What will he do if he wants to advance it more than what the governor can do? What he will do is just lift up this 13 number lever, and once he lifts up this 13 number lever, this cam has to follow the path of the pin, and the path of the pin will be through this slot here. So the pin will push down, or rather the pin movement will be, or rather the cam movement against the pin will be such that the entire cam assembly will be pushed towards the left. You just imagine it, that you are holding this lever with your hand and pulling it upwards. So what will happen? Moment you put it upward, this full cam with the slot has to move along with the pin. So when it moves along with the pin, this cam will be pushed towards the left side. Moment it is pushed towards the left side, this lever, which is hinged at the bottom at this point, will push lever number 9 in a way to change the position of the fulcrum of the suction lever. So the moment this fulcrum is changed, the suction valve will close much earlier. So moment it closes much earlier, it means the injection will start earlier. Because moment the suction valve closes, the fuel inside here is trapped, and the piston going up means that trapped fuel has to be delivered to the injector. So it is advancing the injection further if you lift up lever number 13. And lever number 13 is the chief engineer's prerogative to further advance if he thinks it is necessary. That means when he takes the indicator cards of the engine and he finds that the peak pressure has not come up to what the maximum pressure should be. So then what he can do, he can try and give further advancement of fuel injection with the objective of getting the higher peak pressure. If he doesn't get it, there is nothing he can do. He'll have to put it back in place. Ultimately, he will take indicator card to find out the performance of the engine. And at some stage, with the poor quality of fuel, there is a limit to how much the engine can perform. You cannot expect the engine to perform better than its best, given the condition of the fuel oil. So it is not that even the poorest quality of fuel oil will automatically give you the best power output. It will not happen. It will not happen. So that is why the objective is, even with the poorest quality of oil, we try to get the maximum benefit. In other words, generate the maximum peak pressure even at reduced load. That is the objective. Okay, so let's go on to the reading part of it, where we were reading. Oh, not this, yeah. Yeah, variable injection timing continued. With VIT, fuel regulation is so arranged that the beginning of the fuel injection is advanced in the upper load range. Now, this is important. The advancement is in the upper load range. It is not in the lower load range, because it makes no big deal. The ship is going to run at 85 to 95% of the load during 85 to 95% of its sea life. So long it is traveling across the seas, most of the time it will be running at 90% to 95% load on the engine. So it makes sense to make these changes in this range of operation. In the lower range of operation, you don't need to make any changes because it hardly runs at that speed. On the contrary, you need to retard the fuel injection at those loads. And there are some instances where you can retard it. Chief engineer has that prerogative or that possibility of retarding the fuel injection when it is going at very slow speed. But remember, running a diesel engine at very slow speed is as damaging as running an engine at overload speed. Ideal speed is 85 to 90% of maximum continuous rating. That is the ideal condition. That is the condition where the fuel consumption is less, but you're giving the maximum output. You would get the same output at 100% load. That is the way it is. So running an engine at low load is very damaging. Running an engine on overload is equally damaging. So the optimum level at which the engine should be run is 85 to 95%. I will say 90%. Very good performance. It goes for all diesel engines, not only main engine, but also for your auxiliaries. Your auxiliaries are also diesel engines, and those engines should not be run on low load. As far as possible, try to keep them at 75 to 85 to 90% load. And then only you will see the quality of combustion is good. The health of the engine is also very good. Okay. So this fuel injection is done at in the upper load range that the advancement is done in order to retain maximum cylinder pressures at maximum allowable values. Your maximum pressure should not be damaging to the engine also. You can have any limit of pressure, but it doesn't mean it is safe for the engine. I had told you why. What limits the diameter of a bore ultimately is the strength of the material used for the engine. Technically, we can keep increasing the pressure endlessly. We can make it 500 bar also, 600 bar, but that will not help the engine. We don't have material which will sustain such stresses. So, in reference to that diagram which I showed you just now, that was this diagram. You remember the governor moves linkage 1, that is that vertical link. And that vertical link was moving the L-shaped link, which was crank lever 2. And then regulating the linkage number 3, which was controlling the eccentric for the spill valve. So 1, 2, and 3 are the 3 levers which control the spill valve. Okay, via the eccentric shaft 4, depending on the momentary engine load, whatever load is there at that point of time. Okay, now because of this movement, cam 6, which is that rectangular plate like a cam, is simultaneously moved around the axis by the linkage A. Moment lever 1 goes down, because it is hinged to linkage number 5, it will swivel. And because it swivels, the cam will go upwards. Okay, moment it gets, that means moved around the axis A by the linkage 5. Here is the diagram again. The moment number 1 is moved downward, it will initially move L-shaped lever to cause link number 3 to operate the fulcrum of the eccentric to move your spill valve. Simultaneously, lever 5 will move downwards to cause the cam to move upwards because it is hinged at A. Okay. Okay. So, because it is hinged at A, linkage 5. Next is the raised profile of the cam. What is the raised profile of the cam? You see that slot over there has a raised portion in the middle of the slot. This raised profile of the cam is forced to move along the fixed roller 7 and hence move the linkage 8 around the pivot B by an amount equal to cam lift, which alters the position of the eccentric 10, or to the position also of the position. I have to change this. Okay, which alters the position of the eccentric 10. Okay, that is the suction valve. This in turn changes the closing position of the suction valve, that is beginning of injection. Simultaneously, the opening of the spill valve, end of injection, will be correspondingly advanced via linkage 8. You see, if you advance the suction valve, the linkages are so connected that even the spill valve will be advanced in its closure. So the entire process of advancing is done at the higher load range. So if you remember that circular diagram showing the timing diagram of a two-stroke engine, which says 5 degrees before TDC fuel injection commences, 15 degrees after TDC injection stops. Now, if I advance this 5 degrees to 8 degrees, so I will have to I will have to advance the 15-degree cutoff line to 12 degrees. So from 8 degrees to 12 degrees after will be the injection period for full load condition, because the quantity of fuel ultimately being delivered has to be the same at the full load. Only thing, the whole timing has been changed from 5 degrees and 15 degrees to 8 degrees and 12 degrees. The duration for which the fuel is delivered is the same as per the crank angle. Okay, so that is what he is meaning here. Simultaneously, the opening of the spill valve, which is end of injection, will be correspondingly advanced via linkage 8, crank lever 2, regulating link 3, and eccentric shaft 4. Thus, any influence on governor output, load indicator, and cyber lubrication will be avoided. Cylinder lubrication will be avoided. You see, what he means here, that load indicator and cylinder lubrication. Now, this part is a little branching out into a separate arena or separate entity. That load indicator will tell you how much fuel is being burned, whether it has been advanced or it has been retarded. But that it doesn't mean the quantity of fuel being delivered to the engine has changed. The quantity is the same, only thing that timing has been changed. So that load indicator is indicative of the quantity of fuel being injected into the engine. That's why it's called load indicator. Okay. Now this load indicator also has another function. This function is to regulate the amount of cylinder lubrication oil that is being delivered into the liner for cylinder lubrication. You see, the quantity of cylinder lube oil being injected is not dependent on the speed. It is dependent on the load. So if I were to ask you a question, let me put this up as a question. Suppose the ship, all right, it is fully loaded and it is running at 100 RPM. Okay, the propeller is running at 100 RPM and it is going on its voyage. It is definitely, something is burning. I think they are making toasts in the kitchen. Anyway, so what I'm saying is, suppose the ship is loaded and it is propeller is running at 100 RPM and it is consuming a substantial quantity of fuel, isn't it? The piston is moving in the cylinder liner at 100 RPM at a rate relevant to 100 RPM. There is cylinder oil being fed into the cylinders for lubricating the piston and the liner at a certain rate. Okay, at 100 RPM, and ship is loaded and it is moving. Now, when the ship reaches the port and it discharges all the cargo and it is on ballast, that means it is as good as empty. But to keep the ship stability, you fill up some tanks with water so the ship goes down a little bit and it is stable. That is the whole idea of ballasting a ship. So now that ship is going to return or go to our next port, and it is again going at 100 RPM of the propeller, but it is empty. Piston movement is the same speed because it is running at 100 RPM. So Kumar Gaurav, tell me, will the quantity of cylinder oil being consumed will be less or will it be more? Kumar Gaurav,
Yes, sir.
it will be the same or will it be different? He doesn't know. Ravi Prakash,
Sir, load is same, so consumption of fuel would should be same.
I'm not talking about consumption of fuel. I'm now listen to that question properly. This is a question which I used to ask in MMD. Now the other officers are asking the same question of the students or the candidates. A ship which is fully loaded, is going from point A to point B at 100 RPM. Okay. Now, once the ship reaches port, it discharges the cargo, and the empty ship, and with some ballast to keep the ship stable, is now moving again to the next port to load cargo, but it is empty. And the propeller is again running at 100 RPM, which means the piston is running at the same speed as what it was when it was loaded. So will the cylinder oil, which is providing lubrication for the piston and liner, will it be the same rate or will it be different?
Lubrication oil would be same consumption, sir.
Why?
It is running same speed.
Now this is the mistake. 99, or I will not say 90% of the boys' mistake. No, it will not be the same. You see, cylinder lubrication, why is it provided? For mainly two reasons. One is the frictional condition has to be reduced, so you provide lubricating oil. The second reason is the fuel oil, which has got some amount of sulfur. So that sulfur quantity will vary depending on how much fuel you're burning for each stroke. Okay. When the ship is loaded, then the load on the engine is more, which means the fuel which is being supplied will be much more as compared to the amount of fuel being delivered into the ship when it is empty. It is doing much more of work carrying that whole cargo. It is doing very little work when it is empty. So to push a heavy weight, you need more energy. To push a lightweight, you need less energy. So the quantity of fuel consumed during loaded condition will be much more than the quantity of fuel consumed when the ship is empty. That everybody understands, I hope. Ravi?
Yes, sir.
Okay. Now, the quantity of lubricating oil supplied is for two reasons. One is to reduce the friction, and number two is to overcome the acidity that arises from the sulfur. If you burn more fuel, you generate more acid. And if you generate more acid, you need more alkali to reduce or neutralize that acid. Okay. So how can you give more alkali into the cylinder, or how can you give less alkali into the cylinder? By injecting more lube oil or less lubricating oil. All right. So when the engine is running at 100 RPM, piston speed will be the same, but the quantity of lube oil fed when the ship is empty will be much less. All right. Because the quantity of fuel required when the ship is empty will be also much less. And this is indicated by that governor load indicator. So when the ship is empty, the load indicator will be closer to zero. But when the ship is fully loaded, that time the load indicator will be much high, which means much more of fuel is being consumed, though it is at the same speed of the propeller. The speed of the propeller is the same in both the cases, but the load on the engine is much more. So the quantity of fuel consumed will be much more. Therefore, we need to deliver also the quantity of lubricating oil much more. So this load indicator arm is directly connected with the cylinder lubricating arm, which controls the quantity. More fuel, more cylinder oil. Less fuel, less cylinder oil. So it is not based on the RPM, on the speed of the engine. It is based on the load of the engine. So your cylinder lubricating oil consumption is based on the load of the engine and not on the RPM of the engine. Are you able to understand, Ravi?
Little bit, sir, not completely.
Why? Don't get confused. I will explain again. Farhan has a question. I think since the engine speed has remained same, it will consume. No, Farhan, that is not right. No, absolutely no. Yes, I know this is a mistake a lot of boys made. I have had this experience before. But see, we have not yet started the lubrication chapter. When we start the lubrication chapter, you will see how interesting it is and what goes into it. Now, why do we need cylinder? Okay, we are going off our topic actually. Okay, briefly, if we burn more fuel, we generate more acid. If we generate more acid, we need more alkali to neutralize that acid. Okay, how can you deliver more acid? How can you deliver more alkali in the cylinder oil? In the cylinder by injecting more cylinder lube oil. And cylinder lube oil is not plain lube oil. It is got alkali mixed in it. You see, the engine has got separate cylinder lube oil and separate crankcase lube oil. The crankcase lube oil is not so much alkaline, maybe marginally alkaline. Normally, during my time, it was pure mineral oil with only two additives, anti-rust and anti-oxidation. These were the two additives in the crankcase oil. The cylinder oil is of a different category altogether. The cylinder oil and crankcase oil are two worlds apart. The cylinder oil has much more viscosity and it has much more of alkalinity. These are the two differences with the crankcase oil. And this alkalinity is dependent on the sulfur content of the fuel. You see, and now, of course, we are having new fuel oil with 0.5% sulfur. Before, the sulfur was 3.5%. And before that, it used to be 4% in more. So, cylinder liners used to get corroded very fast. When fuel burns, remember this also, it has got sulfur in it. So, the sulfur will burn to form sulfur dioxide. And with moisture, it will form sulfuric acid. This sulfuric acid is very, very corrosive, unbelievably corrosive inside the engine. And this corrodes. So how do we stop or reduce the corrosion of the cylinder liner? By coating it with oil which has got alkali in it. And that alkali can be sodium hydroxide, calcium carbonate, or any other. So this alkali helps in neutralizing that acid which forms over there. Sulfur dioxide as a gas will not cause so much of corrosion. But when it is mixed with water and it will form acid, then it will be a very, very corrosive agent. You see, where does the water come from? Ravi, where does or let's ask Farhan. Farhan, where will the water come from in the cylinder if sulfur dioxide is formed? Farhan?
Yes, sir.
Where will the water come from to mix with the sulfur dioxide and then it will form acid? These are common sense questions. Your school level.
Sir, acid plus base will give salt plus water.
No. I'm asking you, how is that acid formed? Don't diversify. I'm
Sir,
asking
from
you
the air from the intake, air
air.
charge.
No. Where
Sir,
is the water?
seawater?
No.
Fuel.
Sir,
Make sure you have attention,
sir,
full attention.
sir, to reduce NOx, we spray a little bit of water.
No, over here we are not reducing NOx. We are running a normal engine. See, when you
Sir,
burn,
at low load it will condense.
no.
The reaction of
Okay,
H2 and
From
O2.
bunker.
a reaction of
H2 and O2.
no.
Sir, the
Now,
combustion.
combustion. Azaruddin Khan, you are near the answer. You see, what is fuel? What is fuel? It is a hydrocarbon. All right. So when this hydrocarbon burns, what does it give off? It basically gives out HC. HC is hydrocarbon. So the C becomes CO2 or CO, carbon monoxide, carbon dioxide. And what happens to the H? H combines with the oxygen to form H2O. So whenever fossil fuel is burned, whenever you burn wood, whenever you burn oil, Whenever you burn some fossil fuel, which is a hydrocarbon, you're also generating water vapor. Actually, you're generating water, but because of the heat involved, it comes out as water vapor. Okay, so this vapor is the source of the water to combine with the sulfur dioxide to form the acid inside the combustion chamber. So that is why this acid has to be neutralized, and this acid will fall on the or react with the walls of the cylinder liner, with the piston, with the crown, all these parts. So to avoid it, we use cylinder lubricating oil, which reduces the friction between the liner and the piston rings, and also to spread a layer of alkali. This alkali, when it comes in contact with the acid, neutralizes that acid to form salt and water. Okay, Jaiswal has a question.
Once again, please.
Once again?
Okay, sir, this concept that you explained.
Okay, this concept, when the fuel burns, and fuel is basically a hydrocarbon, which means there are hydrogen and carbon molecules within, let's say methane. So it has got CH4. So the C burns into carbon dioxide or carbon monoxide. Hydrogen burns with oxygen or combines with oxygen to form H2O. That is water. This water cannot come out like water because then it is hot. So it goes off as vapor. So this vapor, when it mixes with the gas, sulfur dioxide, it forms sulfuric acid water vapor, or sulfuric acid vapor, which reacts with the surface walls of the cylinder liner. But the cylinder liner, if it is coated with oil, which has alkali in it, this alkali and this acid, when they react, they will form further salt and water. But this water which is formed again is in the form of vapor. So what goes out from the funnel is actually absolute vapor and gases. Okay, now one thing. Rising levels of carbon dioxide in the atmosphere cause steady acidification of the yes, you're coming, you're on the right track. Dissolves into water and produces the weak acid, carbonic acid, sulfur oxide come from the sulfur present in the fuel oil, while nitrogen. Yes, this is what is killing us. Carbon dioxide, nitrogen dioxide, sulfur dioxide. That is why the whole planet is under a lot of stress. So that is what Kshitij Jaiswal has said, has brought out the real core of all our universal problems. We are killing ourselves. And that is why we have to get rid of using fossil fuels. And if you see Elon Musk, he is one of the champions in the world. He's going to be a big hero. So he is going to do away with fossil fuels. And every attempt is being made to reduce our dependency on fossil fuels. Maybe if you boys think of some ways by which you can avoid using carbon. You see, carbon is the main problem. Carbon footprint. It is causing damage to the entire planet. So this carbon has to be not used for any combustion process. But all our fossil fuels are carbon. Whether it is oil, whether it is wood, whether it is coal, they are all with carbon. And once you burn carbon, you have carbon dioxide. When you have discharged carbon dioxide, you get carbonic acid, like Jaiswal has already told you there. Similarly, for nitrogen oxide, when you discharge nitrogen oxide, you get nitric acid, and sulfur dioxide, you're getting sulfuric acid. So all the acids will ultimately kill us, and we are killing ourselves gradually. It is called, gradual suicide. We are committing suicide. So the pressure is on to stop using fossil fuels, alternative source of energy, solar energy. Then if you can use hydrogen as a source of energy. But to produce hydrogen, you're going to burn fossil fuel and then produce hydrogen to use hydrogen and then say you're very safe. But ultimately, you've already done the damage by burning fossil fuel to generate hydrogen. That also has to be stopped. So anyway, we are going off the topic. Let us finish our subject. Next chapter is coming up soon. Okay. So Jaiswal, now you will not change the topic, otherwise we will not finish our syllabus. Okay, where were we? We were something way off the topic. So I hope you have understood
Last
what
point,
it
sir.
means for. Okay. Simultaneously, the opening of the spill valve end of injection will be correspondingly advanced via linkage 8, crank lever 2, regulating link 3, and eccentric shaft 4. Thus, any influence of the governor output, load indicator, and cylinder lubrication will be avoided. So that load indicator remains in a steady position, though your injection timings have been changed. And that load indicator is a lever which will ultimately control the quantity of cylinder lubrication also. So though your injection has been advanced or retarded, your cylinder lubrication will remain static as what is required for the quantity of fuel that is being burned for every stroke of the engine. Okay, this will become more clear to you when we do cylinder lubrication. Okay, next is the pneumatic cylinder presses on the cam 6 onto roller 7 via the linkage 8 and thus ensures no lost motion over the entire actuating angle. That means it doesn't go rattling from side to side. Okay, that is the purpose of that pneumatic cylinder with the pneumatic piston inside. Next, what we have is called the fuel quality setting. And this fuel quality setting has everything to do with that lever number 13. Okay, now fuel quality setting enables the beginning of injection, that means the closing of the suction valve, with respect to TDC to be advanced or retarded over the entire load range. That means whatever governor can do to advance the fuel injection, the fuel quality setting allows for additional advancement, and it is the prerogative of the chief engineer. And that lever is actually locked with a lock and key. So the chief engineer has the sole propriety of further advancing the injection if he feels that the peak pressures are not coming up even at the reduced load condition. So he will try to get the maximum load even at the reduced fuel setting. That is the way you improve your efficiency and reduce your specific fuel consumption. By advancing the beginning of injection, the lower maximum cylinder pressure from the combustion of low quality fuel can be raised to its normal value. But believe me, sometimes it doesn't happen. Even if you advance, the quality of fuel is becoming so poor, it doesn't burn, but it is fuel. What are you going to do? It will not burn. It is a grade of carbon which does not oxidize. Horrible it is. Sometimes you will get those fuels on board the ship and you will see the performance of the engine dropping. You do everything possible and still you will not get the maximum. So ultimately, the quality of the fuel makes a big difference in the output of the engine. So don't blame the engine solely if it is not able to perform. Even after you check that it can breathe well and the timing of fuel injection is good, condition of fuel injector is right, there should be no reasons why it cannot perform well. The last condition which may cause the engine to perform badly, and very often that is the condition, because we are burning cheaper and cheaper fuel, the quality of the fuel. And that quality of the fuel means how much you will be stressed out on the ship. Okay. Okay, let's go to the next plate. So this was the diagram. You will need to practice this diagram 2 or 3 times. But after you understood the working, the drawing the diagram from memory is a breeze. That will be the case. I know
Okay.
some of you are capable. Some of you are capable and you will definitely do it after one practice shot. You do it and you get it. So in the exam, if you are asked, explain VIT and any jerk pump on how VIT is achieved, then you can draw this diagram or you can draw a Bosch pump. Let's read on what is function of FQS. The device consists of a lockable arrangement pin 12 on which the roller 7 runs in the cam 6 is eccentrically mounted. Here, let's have a look at the diagram here. This is a locker arrangement which locks this cam position with the eccentric. So once it is locked, then you cannot move this handle. I have not drawn the locking arrangement. I can't draw a lock and lever or lug over there, which will, it is just two lugs with two holes in it, and you can put a lock over it. And it will change, it will allow that cam to be in a fixed condition. So you cannot change the cam, because a lot of junior engineers, what they do on the ship, they want to do experimenting and they don't want to inform the chief engineer. So chief engineer is in his cabin. So the junior engineers want to do a little experimenting. So that time they start changing the settings and they want to see what has happened. And they don't want to keep chief engineer involved. And sometimes they can make a mess of it. And it has, I have had this experience because there was a situation where the engine wouldn't stop. That's more dangerous than engine cannot start. So when we were in the harbor and I stopped the engine and it's not stopping. I had a screwdriver in my pocket. I lifted one lever, took one spanner and jammed it between two distance pieces and the engine stopped. The second engineer was behind me and he was observing. So he saw what I did, and later, of course, I called the fitter and I made some adjustments made, and after that the engine was stopping. So one fine day, the second engineer was alone in the ship, and through the movements, I was not there, and he was required to stop the engine. When he stopped the engine was not stopping. So then he tried the same thing what I tried, with the screwdriver in and with a spanner inside that lever, and still the engine didn't stop. And then the alarm started going. So I ran down from the cabin and I found what I asked him, what have you done? Sir, it is not stopping, but I have done what you have done. Oh, fellow didn't understand why I have done it, and he did it. So make sure you understand what you're doing before simply copying somebody else. And you will find you're in trouble. So that the engine didn't stop. Of course, then we put the emergency lever and stopped it. The whole stopping device had worn out. It had gone past its setting. So each time it stops, it used to move off. And then when he tried to stop it again, it moved off again. So ultimately, we had to change that part. But never do something that you don't understand. That was the critical part. So this locking arrangement over here is entirely the propriety of the chief engineer. So once he fixes the cam so that manually it cannot be operated, but the governor can override it. When the governor does it, it can be done. But his personal intervention in advancing the cam is only under his lock and key. So he can do it. Okay. So that is what is the fuel quality setting. By means of the handle 13, the pin can be turned such that both beginning, that is closing of the suction valve, and the end of injection, that is opening of the spill valve, are simultaneously advanced or retarded when the engine is running. In other words, the governor by itself is doing the advancement of both. Over and above this, it can also be done by this lever or handle number 13. Number 13 is capable of advancing the fuel injection and spill over and above what the governor can do. Okay. This is achieved via the cam 6 and the regulating linkages. The range of this arrangement is restricted to 2 or minus or 1 degree retardation. Either you advance by 2 degrees more than what the governor can do, or you can retard by 1 degree more than what the governor can do. That's what it means. Okay. Now that was all about VIT with Sulzer pumps. Now what we are going into is VIT with the Bosch pumps. Bosch pumps, you remember that when the plunger was going up, And once it covered the suction and the spill port, then the injection started. Now, how do we change the beginning of injection? End of injection is very easy to control because it is the rotary position of the plunger which changes the helix relative to the spill port that will change the moment when the injection stops. But how do you change the beginning of injection? Let's read on. The adjustment of injection timing of the Bosch pump helix control is carried out by varying the relative height and suction and spill ports of the barrel. That means the relative height of the spill ports of the barrel and the plunger edge, because the edge of the plunger top that decides to cover or uncover the spill and the suction ports. Okay, so this can be done by number one, adjusting the height of the plunger relative to the barrel. Okay, so the plunger height can be changed by changing the height at the bottom. Some plungers have that arrangement where there is a additional extension part and that height can be reduced or increased. But it's a complicated process. I will keep away from that. We will do the other one, which is a little simpler to understand, and most of the pumps have that. One is adjusting the height of the plunger relative to the barrel, and the second one is adjusting the height of the barrel relative to the plunger. If it is not the plunger height being adjusted, it is the barrel height being adjusted. Okay. If we lower the plunger, it will retard the injection. Likewise, if we lower the barrel, it will advance the injection. Okay. I hope everybody understands that. Because if we lower the barrel, that means the plunger will cover the spill ports much earlier. But if you raise the barrel, then it will take a longer time for the plunger to go and cover the suction and spill ports. This concept has to be very clear before I proceed into the next step. Remember, the barrel is usually fixed. Plunger is also fixed in its movement. But now, if I can arrange for the barrel to be lifted up a little more, then the plunger will close the spill ports and suction ports much later. That means injection will be delayed. Beginning of injection will be delayed. But if I lower the barrel closer to the plunger edge, that means closure of the suction and spill ports will be much earlier. So beginning of injection will also be much earlier. Are you able to understand that, Ravi Prakash?
Yes, sir.
Okay, good. If you have any questions, make sure you ask. So get your concepts very clear. I hope, Farhan, you have cleared your concept regarding amount of cylinder oil and amount of load.
Yes, sir.
Okay, good. Okay, let's move on. Where were we? Yeah. Now here is a diagram of how the Bosch pump barrel can be moved up and down. Let's have a look at this diagram. I'm going to make it a little bigger so everybody is a little more, is visible much more. So let's make it a little bigger. Okay. Okay, I think this is much bigger now. Okay. Now what you see here is the plunger, and I've broken the pump in the middle over here, and the plunger is right in the middle, and this is the helix part of the plunger. I think everybody can recall the plunger, and this plunger goes right through the barrel, and this part is the next part of the plunger. I have not shown the lower parts because lower parts are not required over here, but this part is still the barrel. You see, the barrel is sectioned over here, and once it is broken from here, this part is also the barrel, but it is the outside view of the barrel. And this part is the sectional view of the barrel. You see, sectional view, outside view, isometric view. This, you are lucky to do your drawing in your previous semester. Otherwise, these concepts are not going to be very, very difficult for the 2019 entry batch. They have not done drawing, but I have to show them drawings like this to make them understand any other subject. So your drawing subject was a very important subject, for your concepts to be very clear anytime an engineering drawing is shown to you. You will be able to understand it very quickly. So here you have the sectional view of the barrel here, and if you see on the side there is that slot, vertical slot, which is oval, and inside that slot you have a screw, a locating screw, or guide and locating pin, he has called it. And this guide and locating pin is fitted onto the pump housing, and it goes through the housing into that slot over there. See, the slot is a vertical slot, so the whole barrel can move up and down, but it cannot move in the rotary position because the width of that slot is the same as the diameter of the pin at this point. So it will not move in the rotary position, but it is capable of moving in the vertical position. By how much? By this slot length minus the diameter of this pin. Over here, I have made a mistake by writing total vertical movement. It is not true. It is not the total vertical. This is the total slot height. This should have been total slot height. And the movement would be the total slot height minus the diameter of the pin at this section. That would be the total vertical movement. I have made a mistake here. You all don't make a mistake when you do the drawing. Next one, you write over here, total slot height. Okay. Not total vertical distance of movement. Okay. Now the plunger here. Okay. Now the barrel at the lower part, it has got square threads. Everybody knows what is square helical threads. And this square helical thread, it's fitted into a sleeve. And this is similar to the control sleeve, which operates or works the plunger of the same pump. It is similar, but to avoid confusion of the term, we have used the term timing guide. Timing guide. Okay. It is to divert from using the same term control sleeve, which is being used for the plunger. So this timing guide is fixed at the height wise. In a horizontal plane, it is fixed. But it is capable of rotation. And as it rotates, it is rotating with these threads inside. See, inside thread and outside thread of the barrel. And this timing guide on the outside has got gear teeth, very similar to the control sleeve of the plunger. Now this timing guide has got threads, gear threads, and simultaneously it has got a rack, a control rack. So when this control rack moves in the horizontal directions, it will cause a rotation of the timing guide. And this rotation about the central axis will cause the threads in the barrel to move along the threads in the timing guide. And this will cause the whole barrel to be lifted up or lifted down or lowered down. It will be lifted up or lifted down. So the movement of the rack is going to cause movement of the barrel up or down. By how much? By the difference allowed by this vertical slot minus the diameter of the pin over here. Farhan, are you able to understand what I'm saying? Farhan has disappeared.
No, sir. Sir,
So,
I'm there.
any difficulty in understanding what I am saying?
Sir, I'm trying, sir. Not able to understand in first go, but I'm trying.
Okay, we'll go have another go at it. Now, for the Bosch pump, it is important to have variable injection timing also. You have seen how Sulzer engines have their pumps controlling the suction and spill valves. Over here, we don't have valves. We have the suction and spill port whose position is being changed relative to the top of the plunger. When the plunger covers these ports, then the oil on top is trapped. So when the plunger moves up again, it will squeeze that oil. And that oil under compression will be delivered to the fuel injector. Now, if I change the position of this suction port and spill port a little higher, what will happen? That means the plunger will have to travel much more before it can cover the suction and spill ports. That means the beginning of injection will be delayed. All right. Now, if I lower the suction and spill port a little more, that means the plunger will cover it much earlier. And if it covers it much earlier, injection will also be much earlier. So the beginning of injection can be varied by changing the relative position of the suction and spill port to the plunger. And this is done by moving the barrel up and down. And this movement up and down is achieved through a timing guide and threads on the barrel itself. And the timing guide is kept fixed so that the timing guide does not move vertically. The timing guide is only capable of rotating around its central axis. And this timing guide has got threads on the inside, and the barrel has got threads on the outside at the lower region. And these are matched. And on the outside of the timing guide, you have gear teeth, very similar to the control sleeve which operates the plunger rotation. So when the control rack operates the timing guide will simply rotate around its own axis. But because it rotates around its own axis and it has got a threaded portion over here, it will move the barrel up and down. Consider a bolt and nut. If I were to fix a nut in the horizontal plane and then rotate it, you will see the bolt will go up and down. All right. So same thing over here, the barrel can be considered as a bolt and the timing guide can be considered as a nut, which is in a fixed position, but it is rotating and it is not allowing the barrel to rotate because rotation of the barrel is not possible. The pin here locates that barrel in the rotary position. Over and above that, there is a lot of pressure on top of the barrel and on the shoulder. Actually, I should have made a shoulder here also. A shoulder means a step and it rests on that shoulder, but that shoulder does not make any difference over here because it is going to move up and down. So anyway, so this pin over here restricts the barrel from rotating. So it allows the barrel to only move up and down while the timing guide rotates about the central axis by means of this control rack. So this control rack is again then going to the governor linkages. Similar to your Sulzer pump, you saw link number 3 and link number 9. So this one here is the link number 9 that goes to the governor. If you see that diagram again, no, not this one, sorry. Yeah, link number 9 is controlling the suction valve and link number 3 is controlling the spill valve. Okay, so here in this case, this is going to control the suction and spill together. That means the controlling of the opening and closing of the suction valve. Whereas the control rack, which is operating the plunger, is controlling the spill port. That means the helix, which opens the spill port. So you will have two racks. So this one will be number 9 and this one will be number 3 because this is the one that controls the spill port opening and closure. Now I will show you a pump which is actually there and which has the diagram to make you a little more aware. Now this is your Bosch pump where the whole pump is shown. Now this one here is going to control your barrel movement and this one here is going to control your fuel rack movement. One is controlled, sorry, this one is the one that is controlling the barrel and this one is ultimately controlling the plunger. So these two levers are again going to the governor, which will automatically control both simultaneously, advancing or retarding the fuel injection. This is just to show you. You don't need to draw this. This is to give you a concept of how the Bosch fuel pump has got two control racks. One is controlling the plunger rotation, which operates the spill port, and the other one operates the rise and drop of the barrel, which changes the position of the suction and spill port relative to the plunger. This is an alternative diagram which is easier to draw in the examination if you are asked to show how is variable injection timing achieved by controlling beginning of injection and end of injection in the Bosch pump. So you write over here, this is the diagram. This is actually half the diagram, and this is the plunger. And this plunger is rotated by means of this control rack, which controls the end of injection, and which means the quantity of fuel. The fuel quantity is controlled by rotating the plunger, whereas the beginning of injection is controlled by raising and lowering the barrel. This is the barrel over here, what you see. This is the housing that you see, and this is the guide pin that you see, which allows the barrel to move up and down. And this is the timing guide, and this is the little rack. The movement of this rack will cause the timing guide to rotate. And this rotation with the helix, with the thread, will cause the barrel to move up and down. There's one more point which I've shown here, is this erosion screen. Now this erosion screen screw is intended to avoid erosion of the wall, which suffers from very high pressure release of fuel when the helix is opened. This high pressure fuel oil gushes out. In fact, it jets out from this opening of the spill port onto the wall. And slowly over time, it will cause the wall to wash away. To prevent it, we have a screw which is called an erosion screw, or sometimes it's called a baffle screw. So the oil actually goes onto that screw, and it is shaped in such a way that it flows outward or sideways, or upward and downward and sideways. So the direct blast of the oil does not fall on the housing wall. So this prevents the housing from getting eroded and washed out. Okay, so this diagram is relatively easy, and it can be drawn in the exam. If at all you're asked, explain how variable injection timing of any jerk pump that comes about. So you have the pump for the Sulzer, you have pump for the Bosch pump, or you have this diagram here. Remember one thing, there was one time in the examination hall, one boy asked me, "Sir, can we draw the Bosch pump as a jerk pump?" I felt my entire 6 months effort on that boy was wasted. A jerk pump can be Sulzer pump, what you've seen, or a Bosch pump that you can see. Both are called jerk pumps. Why they are called jerk pumps? Frankly, I don't know. Okay, I'll find out and tell you why they are called jerk pumps. I don't really know. Okay, but I'll find out and I'll tell you why they're called. That's the question I put to myself. Can you re-explain timing valve movement? Which timing valve? There is no valve in the Bosch pump. Ravi, is it in the Sulzer or in the Bosch?
Sir, in this timing valve, I had this question, sir. You said in this two-stroke engine, in this timing diagram which we observe, that the fuel injection takes place 5 degrees before TTC and continues up to 15 degrees after TTC. And
Correct.
if we can modify it to 8 degrees before TTC and bring it, advance it to 12 degrees before after TTC. So how does that take place with this Bosch pump?
How does that take place with this? Okay. Okay. Now here, you have understood the beginning of injection can be varied by movement of this.
Yes,
all right. Sir. Okay. Now, movement of the plunger will change the position at where the helix will cut off.
Yes,
all right.
sir.
So that will give the cutting off much earlier, because this helix is what decides when the fuel is going to get cut off. If it uh, starts the injection earlier, it will also cut off earlier. If it starts the injection later, it will also cut off later. It is simultaneous, because suppose this suction and spill ports is lowered. What will happen? This top edge of the plunger will cover it much earlier. Okay, simultaneously, because it is lowered, the whole the helix will open it even earlier. It happens simultaneously. The closure of the suction spill port will be earlier. Opening of them also will be earlier, because the plunger position will be in the same position to control the quantity of fuel that is being delivered.
Sir, but changing the timing entirely, we need to bring some fundamental changes in the pumps. So I wanted to know what changes take place that the timing changes.
If you want to see now, I have given it a fixed position of 5 degrees and 15 degrees. All right. Now you want to change the fundamental position, you will have to change the cam. The cam at the bottom will have to be shifted. So then you can have a fundamental change of, say, 4 degrees and 16 degrees. Now from that 4 degrees, you can do the advancing by 2 degrees to 6 degrees. And similarly, from 16 degrees, it will come to 14 degrees by means of rotating the control rack of the suction and the plunger. Both. What you're talking about, fundamental change, means the initial setting on the engine. Suppose it is not 5 degrees, it is 4 degrees. You want to make it from 5 degrees to 4 degrees. Then you will have to change the position of the cam. All right. Yes. After setting the cam, then you have 4 degrees and 16 degrees fixed. Now you want to advance that with the load increase. Then that 4 degrees can become 6 degrees before TDC. And because it comes from 4 to 6 degrees, then it will come from 16 degrees to 14 degrees. That quantity will be the same. Are you understanding now?
Yes, sir.
The cam position also has a role to play at what time the fuel injection will start, because it is the cam which is moving the entire plunger.
Yes, sir.
Okay. And Ravi Prakash wants to know timing guide. You see, it is the same thing as control sleeve. In this case, the control sleeve is being used to move the barrel up and down. In the other case, it was being used to change the rotary position of the plunger. The other control sleeve in the original Bosch pump, which did not have VIT, was simply changing the rotary position of the plunger to change the helical curve position relative to the spill port. So this one, instead of calling it control sleeve, we are calling it timing guide. It is doing the same function as your the plunger. Plunger is rotated. Over here, it is made to do vertical. But the control rack in both the cases are simply rotating the two of them. One is the control sleeve which is being rotated, and over here, the timing guide is being rotated by the control rack. That's all. That is why we want to use a different name instead of calling this a control sleeve. It is also controlling. What is it controlling? It is controlling the height of the barrel. All right. So that is why I have termed, in fact, books have also termed it as timing guide. It times the point at which beginning of injection is achieved. Ravi Prakash, are you able to hear? Timing valve movement. You have asked for guide. Timing guide movement. Yes, sir. Got it, sir. Okay. Okay, let's move on. So this is your diagram, which is the Bosch pump. It's a little more complicated because it's got a puncture valve over here. This puncture valve is a valve which is much more of a, not a very old construction. This puncture valve is incorporated in the fuel pump because you suddenly want to stop engines. All you have to do is open the puncture valve. So the delivery after the plunger going to the injector, this is the one that is going to the injector. So the fuel delivery to the injector is from here, and that puncture valve will stop the fuel going to the injector and it will give it into a different passage. So that oil will go out from there and it will be released. So the pressure above the plunger is released instantaneously, which means the engine will stop instantaneously. Because there have been problems earlier when suppose some unit goes defective and you want to stop the engine and then you pull the lever on the governor to stop it. But the governor lever which operates the pump, the pins, multiple pins are there for each pump. Those pins are sheared off. And if that shears off, the governor is useless. Even if the governor moves its load indicator to 0, it doesn't mean the fuel racks will move to 0. Because the link pin between the governor arm and the fuel racks has sheared off. And if it's not uncommon because nobody looks into that, and it is regularly being stressed right through the running of the engine. So over a period of time, a pin, the diameter of a pencil, gets sheared off, and that is controlling all the fuel pumps. And when it gets sheared off, all the fuel pumps will go into maximum mode. So what you have is called runaway engines. And then you try to stop it, it doesn't stop because the link connecting the fuel pumps is broken. So how do you stop this? By pressing a valve, by pressing a button. This button, moment you press, actuates the puncture valve. This puncture valve will immediately open a passage in a different path as instead of to the fuel injector. And this is a high pressure valve because the pressure required to keep it closed is again 350, 380 bar. So you require a lot of pressure. It might be hydraulically operated, it might be pneumatically operated. At the moment, I do not have all details about the puncture valve. So we will skip it. But just remember, the puncture valve is located after delivery valve inside the pump and to the fuel injector. All right. So between the puncture valve and the plunger is the delivery valve. It's a non-return valve which you saw earlier. And so when the puncture valve is opened, the pressure in that pipe going to the injector is instantaneously released. If you open this, it means all the oil from that pipeline will go out. Okay, so that is the way it is. So this is all for today. Any more questions you have, you can ask because I am going to go on to our next PowerPoint. Oh, it is already 11 o'clock. All right, we'll keep it at this
Sir,
as of now. Yeah, if you have questions, ask.
in the soldier pump, sir.
Okay, go ahead.
Yes. So there was this rectangular thing now, what camshaft and
1 second, let's go to the diagram. Yeah, this one, number 6.
Yes.
It
Yes,
is like
sir.
a plate. It's a plate.
So
It is a-
when the 7 pin comes at the middle, then it would be a maximum displacement, na? That would give more torque to this 9 number lever.
See, the 9 number lever has to be pushed to the left or it will be pushed to the right. Okay. So movement of this cam will cause that movement of number 9 either to the left or to the right. As I
And
see
it would be maximum at midpoint of that camshaft.
Yes, they're right. It will be maximum at this point. That means number 9 will be shifted maximum to the left when this pin is in the midpoint here. Right. You're right.
And the corresponding 3 would be giving the spill similar displacement.
Yes.
The 3 number lever. Yes, sir.
That's it.
I thought that would be like independent of each other or something like that.
No. The one thing is there. If you advance the beginning of injection, you're also advancing the end of injection. because beginning of injection is, advancing of ignition, starting of combustion, and advancing of end of injection, that is the spill valve, means controlling the quantity of fuel that is being delivered in the chamber. You cannot simply advance the beginning of injection and leave the spill valve in the same position. Then what happens? The quantity of fuel going in at that load will be too much. You have to regulate the quantity of fuel. Okay, this is what happens. And in some cases, there is something called lambda control. Engines have become very, very refined now. This lambda control is such that suppose you need to increase the load on the engine, or the governor by itself tries to maintain a certain load of the engine. What does it do? It changes the quantity of fuel delivered. Now the propeller, sometimes the ship is going in one direction and the current of the water is another direction. And suddenly the current changes. The water flow under the ship can change its direction. So this change of direction causes a change on the load on the propeller. So the propeller may slow down if the current is such. So what the governor will do? The governor will try to maintain the same RPM. So it will increase the fuel. Moment it increases the fuel, momentarily it gives more fuel than what was required. Okay. So this sudden increase of fuel, and then again it will reduce marginally. So what happens during that time? You're giving more fuel than what air supply you're given. So that part of the fuel will not burn. So you'll get a puff of smoke suddenly. This puff of smoke means some amount of fuel getting burnt out without providing for work. So you have sensors which are called lambda controllers. These lambda controllers manage to control that overshoot of the governor. Governors by themselves prevent overshoot. But to prevent governors from overshoot, you have electronic devices which prevent it. I don't exactly know how and where they work in, but they have these devices in the very modern engines. In fact, most of these modern engines, they are electronics from top to toe, from top to bottom. They are electronically operated in almost every sphere, whether it is fuel control, whether it is valve control, whether it is speed control, everything is under electronics. So in time, be ready to go into a lot of electronics and devices on very pinpoint accuracy in their control. And all that control is intended to get the maximum benefit. Because you see, burning excess fuel is a waste of money. But then spending money to have a whole lot of electronics, and if they don't save you more money by reducing the fuel, that spending money on those electronics is also wasted. So the ship owner has to balance his expenditures. He can make it super automatic and super electronics, but does it give him the benefit of saving that little oil? It doesn't. This is called the Gaussian theory. Gaussian, I think. Gaussian theory. How much you spend money to save money, is it justified? All right. So, because fuel costs are going up, more and more of electronics and automation is coming up. If fuel costs were cheap, then this electronics would not have come in so much. But now electronics is coming up with another purpose, with the intention of reducing pollution. That is also a factor. Okay. So for today, we keep it at this. Next class, we will start with indicator card diagrams. Okay. But improve your electrical machines knowledge, electronics knowledge. Electronics and electrical machines. These have to be your strong points as much as mechanical. because mechanical is now going to be controlled entirely by electronics and electrical. You have no choice. And shipping companies are doing away with Batti Saab, electrician. So the marine engineer has to be the electrician, he has to be the electronics engineer, he has to be a mechanical engineer, and he has to be a naval architect. You must understand the ship structure and ship strengths. So all these combined, you have to be a marine engineer. You have to be a jack of all trades. Okay, that will be all for today. And next class, we will start with what you call the indicator diagrams, power calculations, etc. I'm still making out that PowerPoint, and moment I finish, I will start on that. All right. So that will be all. Take care, and we shall meet again. Oh, today is don't go. Wait. I have something to say. Wednesday, Thursday, and Friday. Sorry, Wednesday and Friday. Who has got classes on Wednesday and Friday? Section E and F and C and D. Yeah. So these 2 days, I will be changing my timing because I need to attend something, a medical issue. So I will be changing the timing. So be prepared for Wednesday and maybe Saturday, not Friday, Saturday. Saturday is ENF. Oh, that means ENF both. So I will let you know. If there are any changes. But be prepared Wednesday, Thursday, Friday, Saturday. Because the doctors also don't want to see you. You have to wait for them and they will give you a timing and then you can see them. So I don't know if in the morning hours I'll be able to attend class. So that is why I might have to change the timing. I'm sure you're all game to attend class even at 5 o'clock in the evening because there's nothing to do from home. I hope you are able to attend. Okay, bye-bye till then. Let me cut off the recording. Okay, take care.
Thank you, sir.